Question 30. Points B and C lie on segment AD as shown below. The length of segment AD is 25 units. Okay. So AD is 25 units. So I like to draw it like this. Sometimes people use like the curly stuff, but I think this is a little neater. Okay. Segment AC is 19 units long, so that's A to C is 19. Segment BD is 14. So B to D is 14. How many units long, if it can be determined, is the segment BC? Alright. So the very first thing I want to mention here is if it can be determined and cannot be determined. Very rarely is that going to be the answer, so you can pretty much eliminate that. Okay. So you have if you have no other idea, you can sort of guess between those four that are left. Don't choose K, right? But I think we have a better idea of that, so let's see. So trick here is to subtract lines that either sort of start at the same position or end at the same position. So the way I see it, we have two choices. On the one hand, we can subtract, say these two quantities. If we do, we'll get a value of 6. And that 6 would have to go in this position here, because it's sort of the missing piece, if you will. Alright, so what we've deciphered there, and perhaps we'll use different color for this. So let's see, we'll use red. Is that this piece here is 6, right? And then alternatively, we can also take this and this, which end at the same position, and start at different positions. So their difference, okay, is this beginning section. And they differ by 11, right? So notice we've figured out two things already, and none of them are relevant to the answer quite yet. But now we can maybe grab two that sort of differ by the amount BC. So let's see if we could find them. And yes, let's say we take this one along with this one, right? So they both end at the same position, right? But they start at different positions. And so the difference can be measured from their difference here. So 14 minus 6 is 8, so that would go here, and that's choice H. Alright. What is the coordinate of the point in the standard coordinate plane at which two lines intersect? So probably the simplest way to do this without a whole lot of thinking would be to use your calculator, right? So let's see if we can do that. Just a moment here. Okay. Here we go. So what is the x-coordinate of the point? Okay, so we want to plug in our y equals minus 2x plus 7. And then second line we'll do 3x minus 3. Minus 3. Graph them. Right, so if you graph something already, it might be sort of at a line here, so you can just do zoom 6. That'll make it standardized. Alright, and if that doesn't give a good picture, you could try zoom 0. But here we can see the intersection very clearly, so we'll just move our cursor a little bit closer. And this is not required, but I like to do this. So I move my cursor toward the intersection and I zoom in. So go zoom 2, enter. So that gives us a nice picture, and now we can do second calculate, and we go to intersect, which is 5. So first line, yes. Second line, yes. Enter. And it finds it for us, 2, 3. So 2, 3 is our point, x, y. And they want to know the x-coordinate, which is 2. Now, if you didn't want to use the calculator, how would you do it otherwise? Well, we've got y equals minus 2x plus 7, and we have got y equals 3x minus 3. So we have to solve this system of equations. So we're going to use the substitution method. So basically, since y is equal to this, I can plug it into the other equation where y goes. Okay. So I end up with negative 2x plus 7 equals 3x minus 3. Then I always start with the x's here, so plus 2x to both sides, and I get 5x, and then I'm going to add the 3 to the other side, so plus 3, you get 10, divide by 5, and you get x equals 2. Okay? For all pairs of real numbers s and t where s equals 4t minus 7, what does t equal? Alright, so we have to isolate for t. So the first step is to add 7 to both sides. Okay, cancels out. S plus 7 is 4t. And then we have to divide by 4 on both sides. Okay. And we get t equals this, which is choice K. Parallelogram ABCD, what is the area? Okay. So we have a formula for this. Area of a parallelogram. That's going to be base times height. And most importantly is this height is not slanted. It is perpendicular to the base, just like in a triangle. Okay. So in this case, the base we could take to be this whole bottom part here. So we do 5 plus 15, which is 20. The height has got to be perpendicular to that and reaching the other base, so to speak. So the height is going to be 12. So we simply have to do 20 times 12. 2 times 12 is 24, add a 0. If b equals a plus 3, then a minus b to the fourth is. Alright, so there's a few ways to do this one. One option is to use the substitution idea. So we take this, we plug it in for b right here. Okay? We have to be careful that when we plug in, we're supposed to use parentheses, right? Whole thing to the fourth. Reason that's important is because this minus sign distributes to make minus a minus 3, okay, to the fourth power, and then these a's will cancel, so we get minus 3 to the fourth power, which is 81. Okay, so in this case it actually wouldn't cost you even if you did make that slight error. Let's look at another way to do this. So we have again b equals a plus 3, and then we have a minus b to the fourth power equals question mark. So another option, if you didn't like that option, is you can rearrange the original to make it look more like what they want you to have. Okay, so one way to do that is you could start by subtracting a from both sides. That gives you b minus a equals 3. Alright, and from there you kind of have it the opposite way around, so you can multiply by negative 1 on both sides, and that'll give you negative b plus a equals negative 3. And then you notice that these terms are in the reverse order, but you can reverse the order as long as you keep the sign in front of the correct letter. Okay, so you can move these circles around as long as the circles include the sign in front. So anyway, yeah, we end up with this, which is really just a minus b. So we know that a minus b is equal to negative 3. So we could take this and plug it in for a minus b. We get negative 3 to the fourth, which is, again, 81. Anytime you have a negative raised to an even power, it becomes positive, right? A park has the shape and dimensions in miles given below. The park office is located halfway between point A and point D. So here's A and point D. Halfway between would be somewhere around here, right? Which of the following is the location of the park office from point A? Alright, so we have to start at point A and we have to march along. Looking at the choices, you sort of go one way and then another way, and you end up at X. Okay, so in particular, we would want to move eastward and southward. Okay, so not east and north, east and south, east and south. Okay, so all the others are good. Now it's just a matter of how much do we move each direction. Okay, well, let's see. So there's a few ways we could look at this, right? But the key thing is to mirror these amounts. So this amount is going to be 8, right? The vertical distance here. And then the halfway distance would have to be 4, right? You can convince yourself of that by similar triangles if need be. Now, looks like this measurement of 12 goes all the way to the edge. So that's kind of too far to the right, whereas this 9 goes just the right amount sideways. You see? So this measurement of 9 is going to be most helpful. And then we could take half of that. That will get us a measurement of 4.5 in this direction. Okay? So we sort of move vertically by 4 and horizontally by 4.5. Okay? So that's 4.5 east and 4 south. Choice B.